Welcome to 3.1. Identify pairs of lines and angles. And notice that our essential question then is, how do I identify angle pairs formed by three, let's get that emphasis there, three intersecting lines? Because we've already talked about angle pairs formed by one, or I guess we'd say two intersecting lines, and there's one point of intersection. So notice there's two lines here that intersect at this one point. And remember how we've talked about how these two dudes that are angles here that are beside each other are adjacent, and they create a line. So this is a linear pair, and all linear pair are supplementary. You guys remember the definition of that? The sum of the two angles is equal to 180 degrees. And then there's also these two angles that are across from each other. The term opposite is the official term. In position, opposite in position. And these are vertical angles. You remember that vertical angles are always congruent. Okay, so that's two lines that create one point of intersection. And so when we're talking about labeling pairs of angles, my first question that you should have on your paper there is, one, are we talking about, or these angles that we are referring to, are we talking about one or two intersections? So again, if we're talking about angles 1 and 2, notice how it's just one intersection. All right, so we've already done that stuff. But now we're going to forge on and be talking about angle pairs created by three intersecting lines. Okay, but before we do that, let's focus on a few important terms for us. So parallel lines. So notice these two lines here. Yeah, they have arrowheads, of course, on the end of them, but notice there's arrowheads kind of in the middle or somewhere inside of these two lines. And that is the geometry's way of communicating to us that these two lines are parallel. You're familiar with that term, but we need to make sure to get the definition clear in our mind. Parallel lines, not only do they not intersect, right? They don't cross each other, but also they are coplanar. They're on the same plane. So maybe we should write that in there, huh? So let's just do that. So coplanar means on the same plane. On the same plane. So like this sheet of paper can represent a plane. It's a flat surface. Also, the way we draw it in geometry is like this parallelogram. This plane T. It's a two-dimensional surface that continues forever in all directions. And this is plane U underneath there. So for two lines to be coplanar, it means that they are on the same plane. They are on the same two-dimensional flat surface. So to be parallel, two parts of the definition. One, they don't intersect. And then two, they have to be on the same plane. Okay, but what if I have two lines kind of like this? Can you see that here? And that they don't intersect. They don't intersect, but they're not on the same plane. So that's going to be skew. Isn't that a strange word? S-K-E-W. So notice it's the same part where of the definition says do not intersect, but they are not coplanar. They are not coplanar. So probably the easiest way for me to show you that is, let me do this one. Okay, so here's your kind of a cube, right? This is a three-dimensional object, and to be parallel, for example, these two lines here are parallel. They are on the same plane and they do not intersect. And also these two are parallel on the same plane. You can make a plane cutting through here on the same plane and don't intersect. And same thing over here. But what if you had these two lines here? Well, they are on the same plane, I'll give you that, but they intersect. So those are not skew. So to be skew would have to be like these two guys here. they're not on the same plane, and they don't intersect. Or you could also do like this guy here. These two, they're not on the same plane, and they don't intersect. Let me try to show you on a two-dimensional drawing, because we got to be able to look at this thing and say, okay, and notice that these lines, like line CD and line AB, those are parallel. And as long as this is a cube, as long as all of these are right angles here, then the same thing for these lines, they'd also be parallel, and then these lines would be parallel. And then to be skew, let's take this line DC still, and line, or segment, whatever, FG. Those would be skew, right? Because they're not on the same plane, and they don't intersect. Okay, so that's our new funky word, skew. Let's talk about parallel planes now. So these two planes here, and can I show you here? Yeah, it might be easier to see it in here, but you also have it on your notes. So these two, what am I doing? Is that going to work? Yeah, I think that's good. So this blue plane T, and also this green plane U, we would have to be told that they're parallel planes. There's nothing, no annotations on here indicating that they are planes. Like you'll remember these arrowheads, right? That tells us these two lines are parallel. But to tell us that the planes are parallel, they just have to write it out and communicate that to you. Let's jump down now. So we talked about this parallel planes, but let me jump down here and continue this concept of parallel. Remember, a postulate, a synonym of that is axiom. Let's just even write that up there just to remind ourselves. Axiom. Remember, it's a statement that does not have to be proven to be true. It's accepted to be true. And what they're saying here is that if we have a line and a point, then there's only one line that can go through that particular point and still be parallel to the given line. So here's our point, and there's only one line that can go through that point and still be parallel to that one particular line. Or the perpendicular postulate, the same concept, that if they give us a line and a particular point, that just like we just said, there's only one line that goes through that point that is parallel. So also there's only one line that goes through that point that is perpendicular. Remember, the perpendicular means it intersects at a 90-degree angle. All right, now let's get into it. Here we go. So let's follow our procedure here on how to determine and label a pair of angles. So remember, first question is one or two intersections. So let's be thinking about points, angles 1 and 2. And notice that angles 1 and 2, there's only one intersection that is associated with these two angles. So again, we're going to drop down here, and these are the terms and the relationships that you would use. But if we're talking about angles 1 and 8, notice there that there's actually two intersections that related to angles 1 and 8. So our next step then would be to identify the transversal. So a transversal is a line that intersects two or more coplanar lines at different points. So here are our two lines, kind of going along like this. In this red line, this is our transversal. It is cutting across the other two. So notice that the black and the blue line, they only have one intersection, whereas the red line, that intersects two other lines. So that's called a transversal. So go ahead and write that on your notes if you would, and emphasize that transversal. So our second step is to identify the transversal. The next step is to ask yourself the question, are the two angles that we're looking at, are they on alternate sides of the transversal, or are they on the same side of the transversal? So for example, like angles 2 and 6, if we were trying to figure out the relationship of angles 2 and 6, they are on the same side of the transversal. Whereas, if we were looking at the relationship between angles 2 and 7, those are on alternate sides. So alternate meaning they're different. Can't get my thumbs underneath the camera here, but they're on different sides. Here's your transversal, of course, the blue. And notice that the angle 2 is on the right side, and angle 7 is on the left side. So alternate means different sides of the transversal, and of course same side means that they're on the same side, either both on the left or both on the right there. Okay, so where we are driving at is it's going to be the relationships that we use is going to be one of these four relationships. And so let me just read these through, and please say these aloud or at least in your mind say them, but I'd recommend you say them aloud along with me. Corresponding angles, and so those would be, let me just read them through. Corresponding angles, alternate interior angles, alternate exterior angles, and then same side interior angles or consecutive interior angles. So same side and consecutive, those are synonyms of each other, different ways of saying the same thing. Okay, so let's pick angles 2 and 6 that we started out with before. So we're asking ourselves, are they on alternate or are they on same side of the transversal? And angles 2 and 6 are both on the right side of the transversal, so therefore they're same side. And then we ask the question, are these angles, each individual angle, is it interior or is it exterior? So think of these two lines here, the lines that are not the transversal. All right, so the blue is the transversal, but think of these lines here as the walls of your house, and interior is inside the house, and exterior are outside of the house. So angles 1 and 2 are exterior, they're outside the house, along with angles 7 and 8 are also exterior. And then these angles, 3, 4, 5, and 6, these individual angles, each of them are interior angles. So for example, let's look at alternate interior. So angles 3 and 4 are on alternate sides of the transversal, different sides of the transversal, and they're also interior. Let me show you this here. This might be helpful to look at. So for example here, interior. We did alternate interior would be angles 4 and 5. So angles 4 and 5 would be alternate interior. And of course angles 3 and 6 would also be alternate interior. Alternate exterior would be angles 1 and 8. So notice they're on different sides of the transversals, 1 and 8, on different sides of the transversal, and also both of them are exterior. And then angles 2 and 7 would also be alternate exterior. And then same side interior angles, or another way of saying the same thing, consecutive interior angles, would be angles 3 and 5. Those are both on the left side of the transversal. And angles 4 and 6 as a pair. They are same side interior. But let's go back to that pair we had before, we started with. How about angles 2 and 6? What's up with that? So they're both on the right side of the transversal. So angles 2 and 6 are same side interior. But angle 2, that's exterior. And angle 6 is interior. It's inside of these walls here. So do we have a same side interior exterior? And the answer is no. That's not one of our relationships. But we do have corresponding. So what are corresponding angles? They're angles that have the same relative position. So please write that on your notes. Same relative position. So notice that, let's do it this way. I guess we do that. So notice that angle 2 is in the top right. So just look at this one intersection up in the top, and angle 2 is in the top right position, and angle 6 is also in the top right position. So angles 2 and 6, they correspond to each other. Maybe I can show it this way. They're both up in the top right position. Notice that angles 1 and 5 also correspond to each other. They're also in the top left position of their respective intersections. And then angles 3 and 7 correspond to each other. And then angles 4 and 8 correspond to each other. All right, so that was a lot. I went very quickly through that. But now you go through and figure out the relationship between angles 1 and 5. So it's going to be one of these 4. And please do write out the whole description of that angle pair for angles 1 and 5. You know, first step is, and let me just give you a hint, that all of these down below are related to 2 intersections. So notice that these 2 angles, 1 and 5, there's 2 separate intersections. Same thing with angles 1 and 2, 2 separate intersections. And then same thing with angles 4 and 5, 2 separate intersections. So we're not talking about any of this stuff here. That's only for one intersection. We're talking about these 4. So the answer that you're going to put for each one of these 3 problems down here is going to be one of these 4. Okay guys, hope that was helpful. I look forward to seeing you in class. May the Lord bless you.